In this video, we're talking about the distributive property, which is a property of algebra that allows us to distribute a multiplied value across a polynomial. So let's look at a couple of examples here to explain how we use the distributive property to expand some of these expressions. So in this first one here, we have 3 times the quantity a plus c. The distributive property tells us that we can distribute the 3 across this quantity a plus c value here. And what we mean by distribute is that we're going to distribute this 3 across the a and the c. So we're going to multiply the 3 by the a, and we're going to get 3a. And we're always going to keep our sign in the middle here, so we're going to get plus, and then we're going to multiply the 3 by the c, and we're going to get 3c. So the distributive property tells us that 3 times the quantity a plus c is 3a plus 3c. And it doesn't matter what we have outside of the parentheses, it doesn't matter what we have inside the parentheses. We're always taking what's just outside and multiplying it by each of the values inside the parentheses. So another example here, we're going to multiply what's in front, mn, by everything inside here. So mn times x gives us mnx. mn times y gives us mny, so we'll say plus, because we have our plus sign here, plus mny, and then we have a plus sign here, so we'll say plus mn times z, mnz. So notice how we just distributed what was in front here across each of the values inside our parentheses like this. And if it helps you, you can draw these lines that connect what's outside to each of the values inside to help remind you to connect this outside value to each of the inside values. Let's look at another example when we have some negative values involved here. So our value out in front is now negative 10. Whenever we have a negative value out in front, we have to remember to distribute that negative sign along with this value here of 10. So we need to distribute negative 10 across each of these values. Negative 10 times x is negative 10x. Here we have a negative 10 times a negative 3, so we always have to include a negative sign when there is one. We have to include that negative sign with the value inside and outside the parentheses. We have negative 10 here times negative 3. A negative times a negative is a positive, so we're going to get plus 30 because those negatives cancel, and 10 times 3 is 30, so we get plus 30. And then same thing here, we have a negative 2a, so we have to include that negative sign, and we'll multiply negative 10 by negative 2a. Our negatives will cancel, and we'll get a positive 20a. Now the great thing about math is that as long as we apply the rules correctly, they work every time. So let's look at an example that sort of prove to ourselves that the distributive property works. Let's look at this example here, 3 times the quantity 5 minus 2. Let's put the distributive property aside for a second and think instead about order of operations. If we use order of operations to evaluate this expression, what we would do is solve for the value inside the parentheses first. So we would keep the 3 on the outside here. That would stay. Inside the parentheses, we have 5 minus 2, which is 3. So we have 3 times 3, and we know that 3 times 3 is 9. So we get a value of 9 when we use order of operations. If instead we use the distributive property, the property that we just learned, what we would do is distribute the 3 across the 5 and across the negative 2. So 3 times 5 gives us 15. 3 times a negative 2 gives us a negative 6, so we say negative 6, or 15 minus 6. And we know that 15 minus 6 is 9, so you can see that the distributive property is a new tool that you can use to evaluate these kind of expressions.